This is what we did yesterday, yesterday or previously. What we have here is we have what's called a linear pair or supplementary angles. So I know that these two guys, when added together, will get you 180. So why don't I do that? 2x plus 4x plus 108 equals 180. I can combine like terms right away. Pew, 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 pew. 6x. Unmute yourself and tell me what I do next before I do it. Hurry.
Subtract 108.
Good. Subtract 108. And then tell me what I would do after I do that. Hurry.
Divide by 6.
And what is that? 100 some? 12? Yes. You say. Yeah, good. Good. All right. That was what we did in the previous lesson. You probably saw something similar to that on the test quiz. It's the same thing. Not the same thing, though. We're going to talk about shapes, polygons, and the name of them. Rest in peace, my man. Rest in peace, baby. May you live forever in our hearts. You are one of the greatest rappers of all time, in my opinion. Died too young. All right, so thank you, Athena. Lots of vocab today. Elena, did you just fall down the stairs? A polygon is a closed figure formed by a finite number of coplanar segments called sides. All right, anyway. Polygon have sides. Sides have to be straight lines. Simple. That's it. Every corner is called a vertex. That's it. Okay, we can name a polygon by using every single letter in that, or every single vertex I get in some type of order. See how this is G, H, J, K, L, M? That's because it's G, H, J, K, L, M. If I wanted to name it, I don't know, I wanted to use a different color. If I wanted to name it polygon, L, K, J, H, G, M, I could, as long as I use all the vertices, which is plural for vertex, and as long as I put it in some kind of order, whether it's clockwise, counterclockwise, doesn't matter which letter you start with. It doesn't have to be alphabetized, as long as you include everything. Okay, and then here's just some fun facts that you probably already knew, but it's just written down. That's called a polygon. All the sides of a polygon are straight line segments. You can't have a rounded polygon. So like, you know, if I were to draw a rectangle, but instead of having an end here, I just kind of poked it out like a little half circle. Can't do it. You can't do it. Speaking of which, those are polygons. Look, they're all connected. Look, they're all connected. Look, straight lines. Look, another straight line. That'd be called a triangle. Look, that'd be called a quadrilateral, and that'd be called maybe a parallelogram. That's not a polygon because it's two polygons connected together. That's not a polygon because it's not closed. Closed means that all endpoints meet another endpoint. This isn't closed, so that's not a polygon. Look at those curves. Shouldn't have said that. That has a line sticking out, which means it's not a polygon, so this part's not enclosed. That has a round. That's just an oval. Ridiculous. So those are the difference between polygons. Two types of polygons that we're going to talk about are called concave and convex. All of these are convex, 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 because they all have How should I word it? They all have exterior angles that are greater than 180 degrees, and maybe that doesn't make sense. They all have interior angles that are less than 180 degrees. In other words, all the interior angles have an obvious corner. You can make like a house out of it. This is a concave. What makes that a concave is there's literally a part of the shape that's caved in. It's like clever in its wording. So convex is any normal shape that we're used to. The moment that it looks like you dug into the shape, that's when it becomes concave. Okay, so this is convex because there's nothing dug out of it. This is concave because that part right there looks like you just ripped a chunk out of some kind of regular looking triangle. Okay, so the vocabulary might seem a little iffy, and I already see somebody in the chat saying question mark exclamation, question mark exclamation, question mark exclamation. Let me quick draw a few examples. Okay, convex. Convex is the normal shapes that we're used to as long as they're straight lines. So this is convex because it's just like a regular looking shape. Okay. Over here, if I wanted to start out that shape by making it look similar, but then all of a sudden I did this, so it looks like it's normal so far. It looks like it's normal so far. I'm going to now cave in. You see what I did? Instead of having things continuously seem to pop out a little bit, I cut in and made a little chunk out of it. It's basically if your shape represents a pizza, concave is when you take a slice of pizza out. So convex, look like this. Concave, look like this. Uh-oh, chunk taken out of it. There's the chunk. I took a slice of pizza out. Athena.
So when it's concave, it's practically a polygon, but it looks like a chunk was taken out of it.
That's exactly what it is.
Okay.
All of these are polygons, but convex polygons are regular looking shapes that we're used to. Concave polygons looks like you took a chunk out of it, and they literally cave in. Hence the name concave. Where do convicted felon bears live? Where do con bears live? Yes, Sandy, concaves. Oh man, probably stuff that you already know, and it's not going to blow your mind. An equilateral polygon has equal sides. Equilateral, equal sides, equilateral, equal sides. Equiangular, not equal angular, equiangular polygon has congruent angles. When you have a polygon where all the sides are exactly the same, like a square, like a equilateral triangle, all the sides are exactly the same, it's called a regular polygon. So this guy right here is what's called a regular pentagon because all of the sides are exactly the same and all of the angles are exactly the same. It doesn't always mean that if all the sides are the same, it's going to mean that all the angles are the same. The best way that I could describe the fact that just because it's equilateral doesn't mean it's equiangular is if I gave you a rectangle, and in a rectangle, all of the angles are 90 degrees, but they don't necessarily have the same exact sides as far as lengths go. All right. See those words there? Know them. You probably know most of them. Triangle has 3 sides. Quadrilateral has 4. You probably know those already. Pentagon, you should know. Hex, you should know. Hex means a curse. That's how I remember hexagon. Heptagon, sometimes also known as septagon, but I don't like septagon, is 7. Octagon, you should know. That'd be a stop sign. Nonagon sounds like 9. Decagon is 10. And that makes sense because deca means 10. You've probably heard that word before. Heptagon, I'm never going to use that one. And Heptagon. I don't know. I didn't know that. Dodecagon is 12. And then if you have a ridiculously large-sided polygon, you just say 13 gone, 14 gone, 15 gone, be gone, if I'm telling you to leave. Yes. Yeah, the only one of these that I didn't know was 11, and that's clear that I don't know it. So what I would want you to know is all the way up through 10 at the very least. Okay, and 12 is not that bad either, dodecagon. All right. When I said all right and hit the arrow, that means move. Name each polygon by its number of sides, then classify it as convex and regular or irregular. Don't worry about the regular. Well, okay. Regular means all the sides and angles are the same. Irregular means not. Okay, so first off, how many sides does one have?
5.
5, which means it's called, at the very least, it's called a what?
Pentagon.
Pentagon, good. So we'll call this Pentagon. Pentagon A, B, C, D, E. Is it convex or concave? Cave is correct because it looks like there's a chunk missing out of the right side of it. So we say concave. What else are we supposed to do here? Is it regular or is it not regular, which means irregular? Is it regular? It's irregular, good. Number of sides, convex, concave, irregular. Okay, take a look at the John on the right. Take a look at the John on the right. Oh, I forgot to send you guys notes. I'm sorry. I keep doing that. I'm a bad teacher. Yes. How many sides does 9? Oh, how many sides does 2 have? It is 9. So it's called a what? Stop it, Camilla. It's called a what? Nonagon. Thank you. I don't have letters, so I'm not going to name it. Wow, this is very laggy. Nonagon. Is it convex or concave?
Convex.
Convex because it doesn't look like there's a chunk missing. Very good. Is it regular or irregular? Are all the sides and all the angles exactly the same? Regular, good. Because all the sides and all the angles are exactly the same. Lit job, everybody. Lit job. No cap. Lit job. You're welcome. So all I need you to do for 3 is give me 2 words. So if I were to give, for example, if I were to give you a sign like that and ask you to classify that, to identify the shape and call it regular or irregular, I would call that an irregular quadrilateral. Okay? So those would the names be. So now, knowing what I said, that's an irregular quadrilateral, what is 3? You could type it out. You could say it. It is an octagon. There's another word that I want to see too.
Regular.
Regular is correct. What about 4? First off, regular or irregular?
Regular.
I agree. And I know you want to say square. And I would accept that. But if this was like a multiple choice problem, they would probably want you to call it a quadrilateral. Wow.
What about the rectangle inside of it?
We don't care about that.
Okay.
We don't care about that. And in fact, when you guys learn how to drive, you're just going to ignore all signs. Drive as fast as you want and do whatever you want because you only live once, baby. You only live once, you know what I'm saying? What do I have for 5? You're welcome, kids. Listen, is 5 regular or irregular, first off? Yeah, I'm going to say regular. You guys are a bit slow on that one. I think you're insecure, and I don't know what for. But I think you're thinking that it's going to be irregular because there's no way that we would have 3 regular ones in a row. But no, this one's regular. And it's a regular what? Please don't make me wait. Excuse me. You're making me wait. Triangle, thank you. Although I guess you can argue that this is a hexagon, and that's what Russ is saying right now. I guess you can argue that this is a hexagon, an irregular hexagon, because these corners are cut out. So although at first glance I would say it's a regular triangle, but I would also allow irregular hexagon because there's 6 sides, I guess, if you were to include the cutouts.
But isn't there one right answer? So which one will it be?
The only right answer is Jesus. Okay, fine. Mute yourself. Wow.
I muted to laugh.
You think it's funny? Isn't he in every call, Paul? Isn't he in every call that we're in? Amen.
Wait, he's in every single call that I've ever had in my life?
Yeah.
Oh, no.
I'm just going to move on. Yuck. These are all, I would like to think that these are all formulas you know already. Even if you didn't, a lot of it's just common sense. The perimeter for any shape is just adding up all the sides. Okay, so the perimeter, add up the sides, perimeter, add up the sides, perimeter, add up the sides. The only thing that's kind of different is they call perimeter in math circumference, and you either use 2 pi r or pi d. Again, these are equations that I really think that you should memorize or have memorized. Hi, Daisy, again. It's stuff that you should feel comfortable knowing and feel comfortable doing. Okay. Triangle is the only area that I think you might forget, and it's half of base times height. The square is just the side squared. The reason why squared is called a squared is because you square to get a square. And the rectangle is length times width, and the circle is pi r squared. And I know what you're thinking, pi r squared, Mr. Perich, pi r brown. Pi r round. Yes. Memorize them. Really quick, without doing anything, what's the perimeter of 6? Be very careful and don't say 22, the Taylor Swift special. What's the perimeter of 6?
44.
Very good. What did you do? I think Lily said it first. What did you do?
I guess the right answer to that would be I added all the sides.
There you go. So we're going to say 44, even though only 2 of them are visible, 44 feet, because you can say 11 plus 11 plus 11 plus 11 or 11 times 4. What would the area be for square?
121.
121. Now, that's because it's 11 squared. Again, squared is called squared because you literally square the sides to get the area of a square. Lots of squares. Remember, and you probably might remember this from last year, but it's very easy to forget. the area of any object is given to you in units squared. The area of any object is given to you in units squared. When you go to the store and you see someone buying carpeting or tile or something like that, it's not going to be like, oh, you're going to get 121 feet of carpet. To me, 121 feet means I take a tape measure and I start over here and I end over here 121 feet later. 121 feet squared means I literally take 121 squares that are 1 foot in length, and I go boom, 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 and I just kind of stack them across the floor. Area is given to you in feet squared. And again, the reason why it's feet squared is because you're literally doing 11 feet times 11 feet. And 11 times 11 is 121, and feet times feet is feet squared. Okay. Whereas the difference between perimeter is you're adding 11 feet plus 11 feet plus 11 feet plus 11 feet, which gives you a total of 44 feet, not 44 feet squared. Okay. If I were to chop off all your feet and just like add them all together, I would just have a bunch of severed feet laying on the ground, not a bunch of feet squared. Don't be stupid. Now, 7 is a circle. So the perimeter is 2 pi r. What's my r for 7?
6.4.
Hey, they just gave you the diameter. I don't care what the previous slide said. I never in a million years will use diameter in a formula unless we're talking about princess diameter. Rest in peace. You probably don't even know who she is. My adult students probably don't even know who she is. 6.4 is the radius. So the perimeter is 2 pi r, or the perimeter is 2 pi times 6.4. In my class, you will always use pi. Don't use 3.14. And I would prefer if you actually did the math. So what's 2 times pi times 6.4?
40.2 about.
It's about 40.2123.
Yeah, all right, whatever. Uh-oh. I lost it. 40.2?
Yeah.
So we'll say 40.2 centimeters or centimeters squared?
Just cm.
Just cm. A is going to be pi r squared. So we already know that r is 6.4. So pi times 6.4 squared. That's 6.4. Anybody have that?
11.3.
Lily, say that again.
Oh, 11.3.
Seems a bit small. 111.3?
Ooh. Wait.
Pi times 6.4 squared.
The answer is about 20.1061.
That's not right either. What is pi times 6.4 squared?
The answer is 128.68.
Yeah, Lily has it. Where did I say to round it to? The nearest tenth? 0.7 then. Centimeters squared because it's area. Oh, 8's too easy because they gave you everything. What's the perimeter for 8? Ooh, Athena was brave for a quarter of a second there.
I want to say 40.
15 plus 17
I
is...
second that.
Huh?
I agree with her.
Let's go for it. Who am I if I don't trust in my own students? The area is going to be... Thank you, Camilla. The area is going to be half of the base times the height. What's the base for 8? What's the base for problem 8? What's the base of this triangle? If I were to lay this triangle flat on the ground, what would the base be? 8. It could be Santiago. So let's go with that. So Santiago is saying, what if we take this triangle that looks like this, right? I know that's not a triangle, but if we lean it up like that, that part that was now once on the side is now sitting up like that. So he is calling that the base, which you are absolutely allowed to do. So if you're calling that the base, what must the height be? 15 or 7?
15.
Very good. The fact that 17, I'm sorry, not 7, 17. The fact that 17 is a diagonal throws it off. What is that, 60?
Yes.
Meters
Squared.
Okay. Too much. Let's do, I think, yeah, let's do 10. Let's skip that one because it requires you do a little bit. And we'll go right to 10 because 10 is a challenge. Find the perimeter and area of ABC with vertices, blah, 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 blah. It's triangle, and it gives you a bunch of points. So I'm going to, that's the worst graph ever. I'm going to do another graph. All right, so I have -1, up 1, 2, and that'll be A. I have B is, I still didn't do a good job graphing. B is 1, 2, 3, up 1, 2, 3, 4, 5, 6. So that's going to be B. And C is 3, -2. My kids are so bad. Immediately my brain went to distance formula thoughts, but I'm going to not do that at all. Are we okay with the graph that I drew? Yeah, and I'm looking at it, and the graph is right. I just felt very insecure about my graph, but it's right. We could do this the easy way or the hard way, and I choose not to do it the hard way. The hard way would be distance formula, and that would be an absolute nightmare. Although that's what I would have to do to perimeter, but I don't have time for perimeter, so we're not going to do distance formula. Okay. Ref, you can jump on a phone if you want to, but we're 8 minutes away from being done. Let's just do the area. And let's just use common sense. If we were doing this on graph paper or grid paper, it would be a whole lot easier. But this is what I'm looking at. I'm looking at a triangle that looks like this. So I'm going to kind of do what I think it was Santi in one of the previous problems did, where he found the base and the height. This is what I'm going to do. If I could take that picture right there, boop, and twist it like that, there's my base. Okay, right here. Come on. Come on. There's my base, and my height is however tall that is. So taking that information, if I take that information and turn it back sideways, this is my base right here. Now, I can find out how long that base is, and it's not hard at all. You ready? I know that this is -2, and all the way up there is 6. So why don't we count? 1, 2, 3, 4, 5, 6, 7, 8. My base is 8 units long. My height is from the very bottom of the base, which is the whole base, to the tippy top. The tippy top is right here. The bottom is over there at 3. The tippy top is at -1, and the base exists at the line 3. So how do I get there? 1, 2, 3, 4. So that length right here is 4, which means my height is 4. The area is going to be half of base, which is 8, times height, which is 4. You tell me. Do I have a unit of measure? Feet, inches, centimeters, meters? No. So we will put U for units squared. If I wanted to find the perimeter, what I would have to do is do distance formula from that to that, do distance formula from that to that, and do distance formula from that to that. And would it be fun? Absolutely. But we don't have time for it. I'm sorry. So,